Hi. Hi. As always, please pause the video before you see me go through the answer. Have a go at it yourself, and then you can compare your answer with my worked solution. Okay. So we've got parametric equations here. So the formula we're going to use is sort of how you would expect. So it's dy by dx is dy by the parameter, which is t, over dx by dt. If dy by dx was a fraction, this is just how fractions behave. The dt's cancel, and you've got dy by dx. So, that's why this notation is so powerful. Okay, so we need dy by dx in terms of t. So, looking at the y, let's rewrite that as y equals 1 plus 2t to the minus 1. So when we differentiate that, the 1 will disappear, and we'll be left with minus 2t to the minus 2. And then when we differentiate x, we're just going to get minus 4. And okay, so they haven't told us how to present our final answer. This possibly technically is good enough, but it definitely looks like it should be simplified. So we've got 2 over 4, which is a half. And then we've got t to the minus 2. But since we've already got a fraction with the half, we might as well just put the t on the bottom and change it to t squared. Okay. Find the equation of the tangent to the curve at the point where t equals 2. Give your answer in that form. Okay. I'm going to just copy that so we can scroll down. Okay, so we're interested in when t equals 2. So let's see what's going on in that situation. Well, when t equals 2, x equals 3 minus 8, and y equals 1 plus 2 over 2. Now, we're dealing with the equation of a tangent. Okay, so tangent is a straight line, so we use y minus y1 equals m times x minus x1. So the y1 and the x1 we have calculated. We've got them. They are just what y and x are at the point where t is 2. And for m, we are going to use dy by dx. So m equals 1 over 2 times 2 squared, which is 1 over 8. So that means y minus 2 equals an 8th times x plus 5. Let's multiply through by 8. We get 8y minus 16 equals x plus 5. It wants everything on the left-hand side of the equation, so we get 8y minus x, minus 16 minus 5, so that would be minus 21 equals 0. Part C. Verify that the Cartesian equation of the curve can be written like that. Now, normally when we're trying to find the Cartesian equation, we make t the subject and eliminate t. The choice of word here, though, it means we should pause briefly and think if there's an easier way to approach it. So when they say verify, it's kind of a weaker statement than prove. So when if they say prove that this is the answer, you can't just take the answer and show that it works. You usually have to derive that answer. But when it says verify, often it just, if it said verify that x equals 3 is a solution, you can just sub 3 in and see if it's a solution. And you don't have to solve. So let's just check if there's an easier way of doing this. If we're verifying the Cartesian equation can be written like that. Yeah, okay, so yeah, so if we expand it, okay. So what was the answer? And then we get plus 3 plus 8, so that'd be plus 11. Okay, so that's what we're looking for. So let's take our equations then. So we want to make t the subject in one and sub it into the other one. So let's make t the subject here. T equals 3 minus x over 4. So sub that into y, we get y equals 1 plus 2 over 3 minus x over 4. So that means y equals, okay, so we've got a fraction going on, we've got a reciprocal, so we just need to flip this second one over. So this becomes 1 plus 8 over 3 minus x. And now we can multiply through by 3 minus x, so we get y bracket 3 minus x equals 3 minus x plus 8. Remember, when we're getting rid of this denominator of 3 minus x, we need to multiply everything by 3 minus x. See, we've got that x minus 3 bracket already. Anyway, let's just expand it all out because we've got this is what we're trying to get to. So this becomes 3y minus xy equals 11 minus x. So move everything, well, actually, we've got a negative xy, so let's move everything to the right. But I'm going to write it as if it's on the left. So we end up with xy, which we wanted, minus 3y, minus x plus 11, as required. Okay, so for this one, read the question carefully because sometimes they do ask you to prove the double angle formula is true, and in order to do that, you need to use the compound angle formula. But in this case, they're not actually asking you to prove. So you should have the double angle formula memorized. It's 2 cos squared x minus 1. Okay. So in order to integrate cos squared, we're going to use that identity. Now, this question has been very helpful in really explicitly telling you the way to integrate cos squared x is to use the double angle formula for cos. It's also how you do sine squared x, because you can use the double angle formula for cos to get an expression for sine squared. Now, this sort of question I wouldn't expect to see now, because this has come up previously, multiple times in past papers. I think it's quite reasonable for the examiner to expect you to just kind of know that you meant to use the double angle formula for cos in order to integrate cos squared or sine squared. So yeah, I wouldn't expect a question to be this kind if it's asking you to integrate sine squared or cos squared. Okay, so in order to do cos squared, we need an expression for cos squared. So we rearrange that top identity. to make cos squared the subject. So we add 1 to both sides, which will give us cos 2x plus 1 and divide by 2. So that means that the integral of cos squared is just the same as doing the integral. I'm going to take that half, the half there, I'm going to take that out as a common factor. So that leaves us with cos 2x plus 1. Okay, so to get the actual value for this, let's integrate. Cos 2x becomes sine 2x divided by 2, and 1 becomes x. And that's between 0 and pi over 2. So sub in pi over 2, we get this half. Pi over 2, so we sub pi over 2 into here, and it becomes pi. Sine of pi is sine of 180, which is 0. Add to that pi over 2. And then we've got to take away what we get when we sub in 0. That just gives us 0, though. So this becomes pi over 4. Okay, so next question, we've got some of the differential equations type questions. 6 marks for this. Let's copy it so that we can see what we're doing down here. We've got a bit of room. Okay. So no situation, we don't have to form the differential equation. We just need to separate the variables. So when we separate variables, we bring the dt up to here, and anything with an x in it, we put to the other side. So that'll be the whole thing is going to go to the other side. Okay, so when separating variables, you can do anything as long as we're only multiplying and dividing. We get all the x's together, get all the y's together, and that's how we end up with it working. Okay, so I'm going to get rid of some of that. Multiply up by dt. We're going to end up with a dt on the right. Then we've got dx on the left, and we're divided by everything. I'm just going to leave the -1 on the right hand side, so that the left hand side is positive. Okay, so we've separated variables. We need to put the integral symbols in because otherwise it's kind of meaningless. Okay, let's rewrite that left hand side. Okay, so now this is one we can do by inspection, just sort of using the chain rule backwards. So integrate this, we're going to add 1 to the power. We'll divide by that power and divide by the derivative of the bracket, but that derivative is just 1. So we're going to divide by a half, which is the same as timesing by 2. And there's already a half there, so that's done. The other side becomes -t. And we're going to put the constant for both integrals just lumped together on the right there. So we want to find t, so that's a general solution to the equation. They've given us some boundary conditions when t is 0, x is 70, so we can use that to work out c. So let's sub that in. So x equals 70, t equals 0. Sub that in. We'll get 70 minus 6 is 64. To the half is 8. So that gives us 8 is C. So that general solution now becomes the particular solution, x minus 6 to the half equals 8 minus t. Now, how does it want it? It wants t in terms of x. I'm going to need some more pages here, I think. So we want to get t equals something in terms of x, so that's just about done. So part B, we've got to read a lot for this just for 3 marks. Liquid stored in a tank, blah, 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 depth is x centimeters. We might need to use this information. Initially, there is a depth of 70 of fuel in the tank. Actually, I think, yeah, that's going to relate. Okay, so it's related. We've got the same equation. Okay. There is a tap 6 centimeters above the bottom of the tank. The flow of fuel out of the tank is modeled by that differential equation. Explain what happens when x equals 6. Okay, so for this part, we don't need to do any maths. We just need to read the situation. If we've got a tank, we've got this is a side view of the tank. There's some liquid in there. Okay, and there's a tap on the side that's 6 centimeters high. So once all that liquid pours out, so x is the height of the liquid. Once all the liquid has poured out and we get to the tap, it's going to stop, isn't it? That no more liquid can pour out of the tank. So at x equals 6, the flow stops, or there is no more flow out of the tank. So part 2, find how long it will take for the depth of fuel to fall from 70 to 200 to 22. How long it will take for the depth. Have we got? Yes, we have got some of that information already. Okay, so let's grab this question and paste it here. Yeah. Okay. So we know that at t equals 0, x is 70. So we're interested at t equals, what time is it when x equals 22? That's what we're interested in. So t equals 8 minus 22 minus 6 to the half. 22 minus 6 is 16. So this is t equals 8 minus the square root of 16, which is 4. So that equals 4. So time taken is 4. What is the units we're dealing with? Minutes. Okay. Okay, so we've got question with x's and y's in the function. So curves defined by that equation. Find the y coordinates of the 2 points where x equals 1. Okay, so to begin with, for part A, we're not actually needing to do any calculus. It's just asking us to mess around with the equations. So we'll get y squared minus, and x is 1. So that becomes y plus 3 minus 5. So y squared minus y minus 2. And now just solve that quadratic. Does it factorize? Yep. Okay, so y equals 2 or y equals -1. What does it want? It just wants the y coordinate. So we don't have to give our answer as coordinate pairs. I mean, if it was saying give the coordinates of the 2 points where x equals 1, obviously we could rewrite those as 1, 2, and 1 minus 1. Okay, so that's part A, nice, easy 3 marks. Part B, we are being asked to find dy by dx, so now we actually need to do some calculus. So for this, I'm going to copy out the equation. Because there's x's and y's all mixed up, in order to differentiate this, we need to use implicit differentiation. So starting at the left-hand side, we just differentiate, and wherever there's a y, we just differentiate normally, but put a dy by dx there. So by that I mean 2y differentiated with respect to x becomes, y squared. When we differentiate with respect to x, we get 2y. Just as if we were differentiating with respect to y, that's what we get. But because it's with respect to x, we get 2y dy by dx. This one is awkward. Now, you may have got if you made a mistake on this, it's probably going to be here because we've got what we've got here is minus. I'm going to add brackets here. We've got minus a product. So we have to use the product rule. So we're going to have to, but it's all been taken away as well. So in order to not make mistakes with the signs, I'm going to put minus and open a bracket and then do the product rule inside the bracket, and then I can worry about the sign of everything afterwards. So x we're going to call u, y we call v, so we end up with differentiate the x and leave the y alone, plus leave the x alone and differentiate the y, so we get 1 dy by dx. Okay, so I've just left all that in brackets because the whole thing is going to have the minus sign. 3x squared just becomes 6x. The minus 5 disappears. Okay. So we've differentiated. We've just got to make dy by dx the subject now. So how many dy by dx's have I got? Well, I've got 2y minus x. So the 2y minus x, that's how many dy by dx's I've got. Everything else I want to put on the other side. So that would be minus 6x plus y. So dy by dx equals, let's write those the other way around, y minus 6x over 2y minus x. Did they give us the answer? Yeah, y minus 6x over 2y minus x. So that is as required. That's nice. We know we've done that correctly. Find the gradient of the curve at each of the points where x equals 1. Now, so we are now going back to part A. There are actually 2 points on the curve where x equals 1. So, oh, sorry, that was what are we doing? Part B. That was part B, I, and this is part B, I. Okay. Okay, so at the point, let's go for 1, 2. Dy by dx equals 2 minus 6 over 2y, so that'd be 4 minus 1, which is minus 4 over 3. And then at 1 minus 1, dy by dx equals minus 1 minus 6 over minus 2 minus 1, which is minus 7 over minus 3, which is 7 over 3. Okay, and part 3, show at the two stationary points, that is what's happening. Okay, so yeah, finding stationary points when you've had to differentiate something implicitly is a little bit more work. So when dy by dx equals 0, well, if dy by dx is a fraction, if a fraction equals 0, the numerator must equal 0. Okay. So what they haven't asked us to find the stationary points, but what we would now do, because the more usual question would be to find the stationary points. We would take this. So what we've found by making dy by dx equal to 0, we found another line. It could be a curve, but we've found a line that is also on the station, crosses through the stationary points. So what we need to do to find where those stationary points are is solve the simultaneous equations. So it's going to be, we know that the stationary points are on this line. We also know that they are on this curve, so we have to solve the simultaneous equations. They are allowing us to stop a little bit short of solving the simultaneous equations. They just want us to show that we end up with this equation, right? Now, notice what's the difference between that equation and the equation we've got? Well, on the equation we've got a y. Everything in here is to do with x. So let's go back to what we've got. We've got y minus 6x equals 0. That's the original curve. So let's eliminate y. So y equals 6x, sub y equals 6x into the original equation. So we get 6x squared minus x times 6x plus 3x squared minus 5. So all I'm doing here is I'm solving the simultaneous equations, but I'm going to stop before I get to the final solution. So all I've done there is, that's our original equation. We've rearranged this to make y the subject. Then we've taken this y and subbed it in. Okay, now I just need to tidy it all up. So that gives us 36x squared minus 6x squared plus 3x squared minus 5 equals 0. Collect all those together, we get 33x squared minus 5 equals 0. And yep, that is what they asked us to find. So we can stop there. More normally, we would then go on to solve this. We get two values for x. And then we would proceed to find the values of y. Because the turning point is on this line, we can just sub the x values into that. So there's not much left to do, actually. Yeah, they've cut you off just as you were about to get the answer, which is a little frustrating, but that is the answer. Okay. So now we've got a differential equation. We're going to have to separate the variables, get everything with a y together on one side, everything with an x together on the other. So if we get the y, remember to get the y onto the other side, we have to divide. So we get y, well, let's call it y to the minus 2 because we're going to be integrating it. And the 6x we can just leave there, but multiply the dx to the other side. Okay, That's the separation of variables step. That's how we solve differential equations at A level. These are just normal integrations. That becomes y to the minus 1 divided by minus 1. And this becomes 3x squared. And we've got a plus c. That is now a general solution. However, they've given us the boundary conditions, so we can plug those in to get the particular solution we're interested in. So minus y to the minus 1. Well, when y is 1, 1 to the power of anything is 1, so just gives us minus 1. When x is 2, so we get 3 times 2 squared. So c is minus 13. So we get minus y to the minus 1 equals 3x squared minus 13. Now, notice they've told us what form to give the answer in. We've got to make y the subject. So in order to do this, let's get rid of that minus sign. And reciprocal both sides. There we go. Okay, we've got another parametric equations question. And they've been really nice. They first told us to find dx by dt and dy by dt so we can find dy by dx. That's a massive amount of help that they've given you. And again, I suspect that's because this is from when this specification was actually new, so people hadn't seen millions of past paper questions asking you to find dy by dx. So they've given you a hint. I really wouldn't expect this much help now, with all the past papers that are available. People, I think, examiners, again, quite rightly could expect you to just be able to find dy by dx without that hint at the start. Okay, so for part A, I'm just going to write it at the side here. So maybe in a different color so that no. Okay. So dx by dt equals 2. dy by dt equals minus 8t. Okay. So dy by dx is the dy divided by the dx. Very nice formats there. Find an equation to the normal to the curve at the point where t equals 1. Okay, so for part B, we're finding an equation of a normal. So we are going to be using y minus y1 equals m times x minus x1. Right, now, unfortunately, we don't have any of these values that we need to sub in. So let's think about where we're going to get those. So the m is going to come from our dy by dx, because m is the gradient. y1 and x1 we don't have because we've only been given t. So t equals 1, x equals 1 plus 2. And if t equals 1, y will equal 1 minus 4. So there we go. We've got our y1 and our x1. And now we need to work out m. So dy by dx at the point where t equals 1 equals minus 4. So our m, remember the normal's perpendicular to that, so it's going to be a quarter. We've got everything we need now. We can do y minus y1, which is minus 3, equals m bracket x minus x1. Multiply everything by 4, we get 4y plus 12 equals x minus 3. Have they said how they want it? No, we can give this in any way we want. I'm going to put everything to one side. So we get 4y minus x plus 15 equals 0. Okay, so for part C, find the Cartesian equation of the curve. Let's grab the curve so that we can work on it down here. Okay. So we need to make t the subject and eliminate it. So x minus 1 over 2 equals t. Now let's take that t and sub it in to y. So we get y equals 1 minus 4 times t squared. So y equals 1 minus... okay, so the 4 is going to cancel, isn't it? Because we get this squared is 4 and that cancels with that. So we're just going to be left with x minus 1 squared, which is minus x squared plus 2x minus 1. So y equals 2x minus x squared. Here we've got a differential equation. Again, separate variables. So the y will divide to the other side. And we can leave the sine t there. And both of those integrals are straightforward. Integrals you should know off by heart. So that becomes log y equals minus cos t. And then we put plus c. Now, this is a general solution, and they haven't given us boundary conditions, so they want the answer as a general solution. We want y in terms of t, so let's just so we want to get y on its own, so in order to get rid of natural log, we have to both sides. So that becomes y equals to the minus cos t plus c. And now this plus c, we can just replace with an a in the front. Okay, that's standard. You can just do that. If you've not seen that before, let me show you why. So this is not, you don't really need to write this out generally, but this is why. So we're adding powers, aren't we? So if we add the powers, if we want to do the opposite of adding the powers, we have to do that, don't we? Yeah. So e to the c times e to the minus cos t. When we crunch those two together, we add the powers. Now e to the c, that thing, well, c is a arbitrary constant. It could be it's all constants. So e to the power of c is also an arbitrary constant. So we can just replace that e to the c with another letter. And the standard one to use there is just a capital letter A. And like I said, you don't need to explicitly say that you have made A equal to e to the c. Yeah, writing the constant as a coefficient of e is a it's a standard thing. Okay, so next we've got a curve. Looks like it's been defined implicitly. Show that a equals 1. Okay, so all we need to do then is, what is a? A is the y coordinate. So we're going to let x equal 1 in the equation of the curve. So we get y plus 4 equals 5 times 1 squared times y squared. Okay. So we can sort of cheat a little bit here. Because they've given us the answer, we could just show that a equals 1 works. And just plug in y equals 1. So we end up with 1 plus 4 equals 5 times 1 squared, which it does. So that would be good enough. I'm going to do I'm going to do a little bit more than they're insisting on. I'm going to actually solve this and get both answers. But like I said, you don't need to do this. Well, we know one of the brackets is y minus 1 because we've been told that's the answer, so that's nice. And does that work? You get 4. Yeah. Okay, so y equals minus 4/5 or y equals 1. Now, a, we are told, is the one that's positive. So a is greater than 0, so a equals 1. Okay. Find the gradient of the curve at P point. So in order to find the gradient, we need to differentiate, and we're going to do it implicitly. So we start with the y, differentiate that, we get dy by dx. 4x becomes 4. And here we've got a product, so I'm going to treat this as 5x squared times y squared. That will be my u and my v. And when I do the product rule on that, I get u dash v plus u v dash. So u dash v is going to be 2 times 5x times y squared. So that will be 10x y squared. And then we add u v dash. So v dash is 2y dy by dx. So this becomes 10x squared y dy by dx. Okay. So with implicit differentiation, that's the hardest thing. It's when there's a product, because you've got to stop yourself and do the product rule, because it's very easy when you just go, you're steamrolling through the equation, differentiating everything with respect to x. It's quite easy to forget that 5x squared y squared is actually a product and needs to be used, the product rule. So let's get the dy by dx stuff together. So we get dy by dx minus 10x squared y dy by dx. And that equals 10xy squared minus 4. We want dy by dx to be the subject, so we're going to factorize this left-hand side. So dy by dx equals 10xy squared minus 4 over 1 minus 10x squared y. Now, they didn't actually ask for that, so we don't need to worry too much about how neat and tidy that is, although that does look fully simplified. But even if it wasn't, we wouldn't need to simplify it, because we just need to find what dy by dx is at point P, which is 1, 1. So that will be 10 times 1 times 1 minus 4 over 1 minus 10 times 1 times 1. So that becomes 6 over minus 9, which is minus 2/3. Okay, is that it? Oh, we also want the equation of the tangent at P. 1 mark. Okay, that's fine. We've got all the stuff we need. Just a reminder, it's y minus y1 equals m times x minus x1. So that will be y minus 1 equals minus 2/3 x minus 1. Multiply through by 3, we get 3. Y minus 3 equals minus 2x plus 2. And let's just tidy that up over here. So, whoops, my hand accidentally went page up. Let's move it up here. So we're left with 3y plus 2x minus 3 minus 2. Okay. More parametric equations. And again, they've instructed you how to find dy by dx, which is really nice. So dx by d theta is just minus sine theta, and dy by d theta, oops, is 2 cos 2 theta. Part 2, find the gradient when theta equals pi over 6. Well, dy by dx is just dy by d theta over dx by d theta, so this becomes 2 cos 2 theta, which is pi over 3, over minus sine pi over 6. Okay, so pi over 3 is 60 degrees, so this becomes 2 times a half over, and pi over 6 is 30, so that would be minus a half. So we're just left with minus 2. Show that the Cartesian of the curve, Cartesian equation of the curve can be written like that. Oh, I've chopped off how many marks that was worth. Let me just find out what. Okay, I had a look. It's worth 4 marks. Okay, so show that the Cartesian equation of the curve can be written like that. So let's grab that so we can work on it down here. Okay, so obviously this isn't technically calculus now, but we now need to find the Cartesian equation. Now, in the examples we've seen earlier in this video, in order to find the Cartesian equation, we made the parameter the subject and used that to eliminate the parameter. Unfortunately here, if we make theta the subject, we're going to end up with theta equals inverse cos or arc cos of x. And then when we sub that in, we end up with sine of 2 times arc cos of x. Now, technically you have made a Cartesian equation, but it looks nothing like, you know, what if you end up ever in maths, if you end up writing something like sine of arc tan of something, it's usually there's another way to go. So generally, when you've got a trig type question, you don't rearrange to make theta the subject. What you do is you find the trig identity that has the functions that we're interested in. So do we know, do we have a trig identity that has sine and sine of 2 at theta and cos theta? Well, the only identity we've got with sine 2 theta in it is sine 2 theta equals 2 sine theta cos theta. Okay, so we've nearly, so we start with that with trig. What we need then is to sub in all these things so that it's in terms of x and y, not theta. So we've nearly got everything. We can just sub that y for that. The cos theta we can just sub with x. It's this sine theta we need to think about a little bit. So let's look at x. What we need is to find an expression for sine theta. So if x is cos theta, well, x squared would be cos squared theta. So x squared would be 1 minus sine squared theta. So sine squared theta is 1 minus x, so sine theta is root 1 minus x. So that's what we're going to use for sine theta. So now sine 2 theta is y. Sine theta is root 1 minus x. And cos theta is x. How did they want the answer? We don't want a square root sign. If you look at the answer thereafter, there's no square root signs. So in order to get rid of the square root sign, we need to make the square root the subject. So that will mean y over 2x equals root 1 minus x. So y squared over 4x squared equals 1 minus x. So y squared equals 4x squared times 1 minus x. Is that in the form they want? Y squared equals kx squared times 1 minus x squared. And, oh, I can see, yeah, I've made a minor mistake here. This should, I've just lost this squared here. So that, okay. And finally, we've got another differential equation. So let's make divide by the root 1 plus 2y. So if we're dividing by root 1 plus 2y, let's just write that as 1 plus 2y to the minus a half dy equals x to the minus 2 dx. And we can just integrate both sides now. So this becomes 1 plus 2y. Add 1 to that power, we get a half. We've got to divide by a half and divide by 2. So if we divide by a half and divide by 2, they just cancel out. And then we have x to the minus 1 divided by minus 1 plus c. We've got y equals 4 when x equals 1. So that gives us 9 to the half equals minus 1 plus c. So c is 4. So let's just carry on over here and make another column. So our answer then, we've got 1 plus 2y to the half equals minus x to the minus 1 plus 4. I mean, that's a solution. Okay. I was going to say right. It's part B where we've got to make y the subject. Okay, fine. So yeah, so in order they're giving, so it's 8 marks essentially for solving the differential equation, but this last bit of tricky algebra, they've split off into part B. So let's leave part A at that, and then for part B, let's start with the answer we got. So we want to make y the subject. So let's make, so square both sides. We get 1 plus 2y. Okay, so now we just need to multiply out that right-hand side. and make y the subject. So subtract 1 from both sides and divide by 2. So we subtracted 1 and divide by 2 each term. No, let's not do that. Let's subtract 1 first. Yeah. What I said could be interpreted differently, I realized. So let's just do both of those 2 steps in 2 steps. So that's 2y equals that. So y equals 15 over 2 minus 4 over x plus 1 over 2x squared. Is that what they asked us to show? They've taken a half out as a common factor. So if I take out a half, we're going to be left with 15 minus 8 over x plus 1 over x squared. Is that what we wanted? Yeah. Okay. Thank you for watching.